participants come. You can share your slides also and check, sir, once. Just
Yeah.
Vikasji, you will introduce, right, sir? Vikas? Dr. Vikash is not. Dr. Satyaprakash, can you just check your presentation once?
Yeah. That's what I'm doing that.
Right.
Yeah. Share content.
Yes, sir.
It's fine.
Yeah, sure, sir.
So this is my screen. Wait, let me check my Eclipse.
Browser also you can check.
My IDE. Yeah. Earlier my PPT. Now this is the tool which I am going to use for today's
presentation.
Yeah.
Yes, sir. It has come.
Yes, sir. Visible.
Visible, sir. Clear.
Fine. So top to bottom. So from your side, you are able to read the coding also.
We are able to read, sir. Yes.
Okay.
Great.
See, first half I'm going to deliver lecture, then second half I'm going to show the demonstration with explanation.
Right. Great.
So what about the audio? Audio is fine?
Audio is fine.
Audio is fine.
Okay.
So now you are based out of Bangalore.
No, Anutantra, yes, we are having there, and we are having one more in Salem also.
Oh, great. That's great. Vikas ji, आप ready है ना?
Sir, hello.
Yeah. Okay. Yeah, I think we can do 5, 1 minute और रुकेंगे फिर शुरू करें.
Yes, sir.
200 touch होते ही. Yeah, Dr. Satyaprakash, when you complete your lecture around 1 hour, you will just give a 5-minute break, sir, because we are trying to record 1 hour videos. So we will exactly do the. After that, you will just tell that we take a break. At that time, they will change the video. They will stop the recording and start the recording.
Sure.
Just for that. So exactly, don't have to stop exactly at 1 hour. Anytime 4 or 5 minutes this side, that side, no problem.
Yeah, based on the flow, we will.
Yeah, content is being covered. You can.
Yeah.
We will. Sir, you may actually give a little bit brief idea about Java development kit also. Some of them are struggling. They were asking in the group also.
Okay.
So, maybe you can start with that. Meanwhile, the lecture is going on. They will complete their work also.
Yeah, that I will.
Yeah, sure.
Yeah.
Over to Vikas.
Okay, thank you, sir. So, all participants and Satyaprakash, sir. So, let me briefly introduce, sir. Satyaprakash is Anutantra Private Limited. He is Chief Operating Officer for the same. He is an IBM Quantum Education and has been conferred Journal of He also filed publishers. He has also served as technical program committee member at International Conference on Quantum Machine Learning and resource person for more than 20 events in quantum computing. So with this brief introduction, I would like to hand over the session to Dr. Satyaprakash. So over to you, sir.
Yeah, thank you so much, gentlemen, Professor Emmanuel Pillai, Vikash, and your teammates. It was a wonderful afternoon going to be for this quantum enthusiast. So, am I audible?
Yes, sir. You're audible, sir.
Am I?
Yes.
Okay. So let me start with the presentation. I hear there is some requirements regarding the Java installation. So you can. So is it my screen is visible now? Wait, let me. Now it is visible.
Browser is entire screen is visible, sir.
Okay. So Oracle downloads. So here you can specify Oracle Java download and a specific version. So and you can specify the numbering JDK 11. So it is suggested that you can go for JDK 11. So from here you guys can download Java SDK software development kit. So oracle.com. So there you can check in which document you need to download. So we are looking for Java SDK. So let us start. Right. Strange effects, a quantum computing Java tool. So we are interested in learning about quantum computing. So there are multiple ways to explore quantum computing. Python, C Sharp, and in Java also we can able to explore quantum computing. The strange effects is an API which belongs to Java. So that package name is called Red Effects, Strange Effects. This all these libraries which is dedicated to quantum computing functionalities. So Red Effects, Strange Effects is a fascinating project that provides Java-based API for quantum computing. It allows developers to create and simulate quantum programs using Java, core Java code. Specifically, we can say core Java. So if we say core Java, then only people can able to understand. We can say this core Java. So then there is code along with that. There is visual editor also available for Strange. We are having visual editor also. So it will help us to design quantum circuits. So I think the participants are aware of quantum computer, quantum gates, quantum circuits, quantum operation, and the measurement. So quantum circuit is the core part of any quantum computing. So strange effects is a package used to do quantum computing operations using Java. So with the help of that, we can write code as well as we can visualize. So let us take a look of architecture of Strange. So if you write a code in Strange, it will be converted to Java exe. Then it will be treated as an API, then given to the quantum core layer. From core layer, it will either runs in a local machine or else run in actual hardware, or which we prefer there it will be executed. So this is the flow of architecture of Strange. So core Java code, API, convert to API, then given to quantum core layer. Either it will be executed on local host simulator or any cloud environment or in real hardware. So we don't bother where it is running, either local host or in cloud or in actual hardware directly. So this is the architecture of Strange. So how it works? So Java application, so simulator and workflow. This is the internal procedure and the basic blocks. Right. Now we will enter into strange effects, the quantum computing tool. So it leverages a quantum software. It is exported as strange project. So this hyperlinks will take you to the exact. So if I click here, it will bring you to quantum strange GitHub. So where all these packages available. And this hyperlink is to bring you to the documentation of that particular. So strange and their concepts and the sample code for that. So as I said earlier, there is UI editor to create quantum circuit with a drag and drop interface. But today we are going to focus how to write code to have quantum future, quantum operation, quantum gate, quantum circuit, and quantum measurement. So we can do that using core Java in two ways. One is using Maven, other one we can use Gradle. So these are two deployment tools, Maven or Gradle. So we can integrate this deployment tool in any of your IDE. You can use Eclipse, you can use NetBeans, you can use IntelliJ. Still you can use editors, that is fine, but the thing is what we need to have a deployment tool. So I suggest use any comfortable IDE, Eclipse, NetBeans or IntelliJ. So I am going to use Eclipse and Maven. So this strange will support either Maven or Gradle, right? So Maven is a deployment tool. So I think if you are aware of Java programming, there is a process called including jar. So the jar files only enable interface between the user and the programming environment. In order to have those features, jar files should be added to your programming path. So it is very tough. Manually, if we configure those jar files, there will be n numbers. So it is very complex to handle various or multiple jars. So Maven will take care of those deployment. So here are some key features of Maven. Pom.xml. So how it is configured? So it is like a shopping cart. So suppose we are having the shopping cart. If we specify that, it will arrange all those jar files in the central Maven repository. So that is what the pom.file, project object model. Once we create a successful Maven project, immediately it will create the file structure. At the end of the file structure, there will be a file called pom.xml. So whichever we prefer, that should be included in this pom.ml file, whereas this pom. Means project object model. So this file only what does the dependency management. Whichever jars we are required, that will be automatically loaded from actual repository to the centralized repository of the Maven. So that is the beauty of Maven, is one familiar deployment tool for Java programming. Not you can use Gradle also. So either you can use Maven or Gradle. So we have seen about Maven deployment tool, right? So once we done the code, finally we need to build the code. So that is called build life cycle. So during this phase, what happens? Validation, test, and package, verify, install, all this will take place during build life cycle. It will be taken care by the Maven. Then the another part. So earlier I told regarding the dependency. Suppose if you want to add any plugins for your project. So plugins, maybe I can say extension of your code or anything, right? that will be specified with the help of plugins. This field is also comes in the area of form.xml. So then installation of Maven. So there we need to you need to check in internet for Maven download. So for that, if you use Windows, there will be a separate version for Windows, or if you are using open source, there will be Maven with respect to the operating system which we will use. Right. So this is the link where you can find Maven. So Maven dot apache.org download CGI. So from this link you can able to find the archive REXE. Then look at here. So there is a procedure to install Maven. So once you do that, we need to configure path. So the path should leads to this folder, bin folder. So once we configure that, then it is possible to see the successful installation of Apache Maven. Right. So here are the, so there we have received with the zip file. So unzip it, and there is an exe file. Usual, you double click and execute. Then what? So what we need to pick? We need to pick the path till bin. So here exec file, once unzip, copy the path of the extract file till the bin. So this is the screenshot. Pick and paste to the path. Then how to set path? So I think if you people are from computer science background, you may aware. So we need to go to environmental variable. In environmental variable, we need to select. There are two category: user level category and system level category. Always go behind the system level category. Look at the last. So there is two part. The upper one is user level. The second one is system level. So there you have to paste whichever we copied from the earlier step. After unzipping, till bin should be copied, under that environment variable will be configured. Step 1, reach environmental variable, click. There is two category. In both sides it is possible, but I suggest you always, irrespective of user, we can go through system variable. It will provide flexibility to all users. So here we need to configure the Maven installation. Then we need to create a new variable. So whatever we have copied, that should be pasted here. After pasting, click OK. Right. So once it is successful, if we give MVN, so it is shorthand notation of Maven, MVN hyphen version or MVN minus V will show us the whether what we have installed Maven and successfully path configured. Right. Let me stress once again here how to verify. We need to go to command prompt. From there we need to type cmd. There we need to type mvn hyphen minus v. Right. It will brings out the successful installation. If it is successfully installed, this pop-up will comes to the screen. Likewise, earlier I told Java, right? That also verified. So once you have installed Java, there is a procedure available in the documentation to verify that Java version. We need to verify version as well as Java compiler. So these are all the two. If it is successful, it blinks, the cursor blinks here at the username of your system. So Maven and Java. So this is a very important step. Suppose we are using Maven, this is the procedure. Then Gradle, the Gradle procedure is separate. MVN minus version or MVN minus V. So next, here, so most of the times there is the complexity in creating a Maven project, right? So assume that already we are having Java installed, then Maven also installed. So from Eclipse, we need to create Maven project, right? So procedure is the same. Note down the procedure. During the demonstration, I will show how and where and what. So click file new, click file new. Then there will be multiple items will be coming there. There you type project. There we need type project. Then it will show multiple projects. Java project, Maven, C, C++. There we need to select Maven. Then here it is the thing. It is very tricky. While creating any Maven project, it must mandatorily we have to select archetype. Archetype. So there we need to specify quick start. Quick start. So then group ID, artifact and snapshot. Listen, this group ID we need to provide a name with respect to the service provider. So that is company name we can say. Artifact ID is the project name. Suppose today my lecture is based on quantum. So project name will be demo quantum. Project name will be given as demo quantum. Company name will be in dot anutantra or in dot so whatever it is. So that is group ID and artifact ID. Snapshot. There is a field is to be selected or specified. It is simply versioning. So keep it always 1.0 with respect to version. First time we are going to deploy that 1.0. Suppose it is second and third time, the numberings will be varied 1.1, 1.2, so on. So as of now, our snapshot is 1.0. This is how to create a Maven project. So right, earlier I told the outline about form.xml. Look at here. So it is an XML. So computer science background people know about XML. So the beauty of XML is having customized tags. Whatever we wanted to provide inputs to the Maven, that should be given through form.xml. So there is inbuilt tags will be there. So inside the inbuilt tags, we need to provide customized tags. So we need to work on two things. One is dependency. So start tag for dependency and end tag for dependency. Then I was telling about plugins. In order to define plugins, start tag of plugin and end tag of plugin. In between the start and end tag of dependencies, we need to configure dependencies. So this artifact ID will bring, so what are all the dependencies required for the artifact ID, that will be automatically downloaded by the Maven repository and will be loaded to the centralized. So this is, there is a repository called centralized repository. We being a developer or what a client, we need not do anything for this. It is maintained by the Maven team. Whichever the jars or a package is available, right, that will be owned by Maven for sure. So that is the beauty of Maven. Then properties, in short, form.xml automates dependency management, builds, configures and runs the project. Right. Take a look at here. So as I told earlier, this is a dependency to be what? So here we are saying the Maven word. I am going to work with red effects. So strange. This is the project name. and this is the package name, and this is the version numbering 0.1.3. This should be configured in your site pom.xml file. This is the dependencies required for strange. Make a note: open tag and close tag, dependency slash dependency. The next is plugins. So in addition to the jar files, suppose we have any extensions that is specified through plugins. So in our strange renderer, there is a function or a tool used to visualize that is called renderer. So that is specified through plugins, right? So under build open tag and close build tag, we need to include plugins and end tag of plugin. Then this is if we have multiple, so in order to specify that plugins, so now we are having specific plugin open, plugin close. So this is the plugin used for Maven to have visualization renderer. So that will be given here: group id, artifact and version. This is not variable, this is what fixed to with respect to the module which we are using, right? So being a developer, we need to configure dependency and plugins, right? Let me repeat here: in order to have the required dependency, we need to configure inside open tag and the close tag of dependency, group id, artifact id, version. So this is to configure all the jar files to the Maven repository. Next, to have extended plugins that is specified inside build plugins. Inside plugin, the specific plugin, open plugin and close plugin, the same like earlier: group id, artifact id and the version. So these are all not we cannot give just like that. This is with respect to the package. You just simply copy paste. So at the end I will provide these fields for you. You can copy paste from here to your own pom.xml. So this is regarding your dependencies and plugins. So this number shows the quantum computing Java's visual editor responsible for creating the quantum circuits org.redfx.strange. Build plugins. So as I told earlier, right, the plugin. So this is responsible for what are all the extended items we need to run for a Java code. org.openjfx, then javafx, the naming conventions which is used inside. So here we are specifying in any specific version we need to run. So this is the beauty of the Maven, and it is pom.xml. So this tool allows us to build a quantum computing app with using strange fx package from javafx. So it have all the latest features of Java. Right now this is about Java and Maven project. So before going to Java, the system should have Java successfully installed. Then we need to install Maven, configuring path, then creating Maven project. Once we create the Maven project, inside the project there is a file called pom.xml. So this is to be followed while creating your Maven project. File, new, and project type Maven, archetype, quick start, and there is a thing about the selecting arcs type that I will show in the demonstration. While selecting the quick start, it should be from a specific repository. That name I will show, that you note it down. From there only you should pick the archetype, or else what will happen, the project should not be created successful, it will close in between. If we select a wrong archetype, what will happen, we are not able to create successful Maven project. It will terminate abruptly in between. So while selecting the archetype, I will disclose the entire naming of that. So fields inside that: group ID, artifact ID. Group ID is the company name, project ID is project name. Snapshot is the version management. So suppose we are deploying as fresh, it should be 1.00. If it is a revision, with respect to revision number revision, we can keep it as 1.1, 1.2, 1.3, so on. Right. So pom.xml is place where all the configuration done. Dependency exact. So this is to be included in the dependency area, and this is to be included in the plugin area. So now we have configured Java as well as Maven. Now we will enter into some basic concepts of quantum computing. Right, qubit. So qubit is a shorter version of what? Quantum information bit. Q bit is a combination of states 0 and 1. It's a basic unit of quantum computing. Similar, it is similar, but it is not same as the classical bit. So this is representation of classical: 1, logical R, and 0. But what about qubit? 1, logical and 0. So this is the basic representation of qubit. Right. First and foremost feature of qubit is what? Superposition. So I think if you are familiar, or else fine, I will give an outline. Superposition is what? An existence in linear combination state. Psi, we can say alpha times state 0 plus beta times state 1 is a linear combination. So that time, what is that? Possible for a qubit to be in superposition. Next basic idea of quantum computing is that qubit followed by superposition. Then entanglement. This is very beautiful thing in quantum computing. Entanglement. When there is qubits, namely we can say q1 and q2. So by nature we can combine it. That phenomenon is called entanglement. That combining one qubit with the another, that is called entanglement. So technically we can achieve entangle by having Hadamard gate along with the combination of C0. Hadamard plus C0 yields us entanglement technically. Then measurement. This is the most important step in any quantum computing. So the basic part is going to be qubit. Suppose we are having qubit, then what is to be done in the last step? It should be measured. So whatever information available inside that, it should be viewed. So that process is called measurement. So before any measurement, it should be in the linear combination. It will be in superposition. Once we start measure, what will happen to the qubit? Qubit breaks into various number of states, and those will be called as, that is a natural state. It is not a superposition state. Means we can say it will be 0, or we can say it will be 1. So it is observed as normal. Once collapse, what will happen? superposition of qubit will be decomposed into normal state 0 or 1. Right. So here what? So that is the outline we have seen. So in order to work with strange package, so we should know about the various components of strange effects library. Program, step, result, complex, qubit, quantum execution environment, and so on. So right. Then so these are all the various classes or interface that will help us to write Java code for quantum computing. So program class represent a quantum program composed of series of steps, gates, and qubits. So suppose we are having the program class, instantiate that class with the help of the program instance. We can able to have step, gate, and we can provide qubits. So for that program classes required. Next, a class is called step. Suppose we are having multiple operations in a quantum application or a program, that each will be represented by using step. Representing a step quantum program groups states and gates along with the qubit. So this step is responsible for data manipulation. Next, result. So as I told you, in qubit we need to measure. That process will be helped with the help of result class. Holds the results of a quantum computation after program is executed. See, program is not a code. See, this program is the entire quantum procedure. Program means not the code. This program is the entire quantum procedure. So that is what quantum computation after program is executed. Next, complex. So this class enables the developer to handle what? The complex number which is used in quantum computing. In general, normal integer is not enough to handle quantum computing. So we need complex number. So for that we need complex class. The next class is going to be qubit. So this class is the reason for acquiring the qubit instance. With the help of qubit instance only, we can able to store and retrieve information and to measure. As we seen earlier, what is that? If we have quantum information, it should be retrieved or read, or it should be what? Gathered. So that is done by using qubit instance, right? This all the above behavior is stands over the quantum execution environment. See, we all know Java is a object oriented programming. So what is the base of object oriented programming? In order to carry out any operation or function, we need that required object. So for program operation, we need program object. Step operation, step object or instance. Technically speaking, it's called instance. Result function or operation, result object or result instance. Complex operations, complex instance or complex object. Qubit operations, we need qubit instance or qubit object. So in order to keep all this, we need an environment called quantum execution environment, baseline for any quantum computing code in Java. So with the help of this quantum execution environment only, what is possible? The remaining all these steps are possible. In short, we used to say QEE. In short, we used to say QEE. So I think you people are aware. So Java programming contains classes or interface. So 100% whichever we are using, that will be available in not in the java.lang package. So why I am saying this point here? Suppose we don't write any import statement, it means that all those items are available in the java.lang package itself. So whichever we are going to use here is what? It is not from java.lang package. It is belongs to redfx package. And strange is the module. And what is that? It belongs to which package? So this is the import statement which is required. So whenever you write any program in the strange tool, so what is mandatory? To write the corresponding import file for that class or the interface is what? Mandatory. Because why? It is not available in java.lang. It is from a specific package called redfx. Now we will see the remaining operations. Then gate, like classical computer operation, in quantum computer operations are carried out by using gate. So there are single qubit gates and there are multiple qubit gates, starting from Hadamard, Pauli, Toffoli, phase, identity. So these are all various gates which is going to be of category single qubit gate. Quantum simulator. So this is a component which is responsible to simulate all in the programming environment, is the quantum simulator. So right, so please make a note here. Which statement to be imported? Arg dot redfx dot strange. So dot star means it imports all the subclasses from the package redfx and strange. Those are not included. So those are not included. So it is explicit. We need to import with respect to those classes. Now we will see quantum gates. Hadamard. So Hadamard is a pure quantum gate. Implements superposition. So means what? Superposition is what? The linear combination of two states with the probability amplitude. Psi is what? Alpha times of state 0, beta times of state 1. So if we apply Hadamard gate to a qubit, what will happen? Hadamard will equally divide the states into 50% of state 0, 50% of state 1. Holy. So is what? Similar to our NOT gate. So whatever state will be given input to that state, then it will flip into the opposite state. So that is what? Pauli X, Pauli X, Y and Z. So it is simply what it does, flipping the qubit state. Then Pauli Y, Pauli Z, C naught. Yeah, C naught is a category which belongs to multiple qubit gates. So far we can operate Hadamard, Pauli, then swap identity will be with single qubit. Here is a highlighted gate called controlled, is a shorthand notation of controlled NOT gate. We have two qubits. One qubit is called as control gate. Another qubit is called as control qubit and target qubit. Implements controlled NOT gate. Two qubit gate flips the target qubit if there is a statement. So what is the important takeaway in C naught is what? If the control is going to be state 0 and there is no changes in the target qubit state. Suppose controlled gates state is going to be 1, then the corresponding target gate's state will be flipped. So that is the beauty of C0. Then swap gate. So whatever there is a state between the qubits, it will be swapped by using swap gates. Toffoli implements controlled NOT. It is a 3-qubit gate. So what is the beauty of this Toffoli is what? It is reversible. We can reverse into the required state in the initial. Then rotation. So qubit around a specific axis. There are x-axis, y-axis and z-axis. With respect to the qubits given axis, the final rotation will be carried out by using rotation gate. Measurement. Yes, so measurement is the process. In classical computer, if we say or call it as result or program execution. In quantum computer, there is no such terminology. It is called measurement. So if there is a qubit, the qubit state will be measured or it is decomposed into classical state 0 or 1, which is the available information inside the qubit. Identity gate, it is to replicate. It is like amplifies whatever gate which we are having, sorry, whichever having the states, that will be replicated. So that is what identity gate, which does nothing and leaves qubit state unchanged. Phase angle, phase angle shifting is done by using phase gate. Phase rotation to the qubits state 45, 90 and so on. So now let us see the first component of the quantum programming using strange. So simple quantum execution environment. So this is the first step. In order to having quantum app or quantum application in strange package, new keyword will be provided and we need to execute the constitute. We need to call the constructor of simple quantum execution environment along with the new keyword. It yields the instance of simple quantum execution. With the help of the QEE, we can do the further steps, program, step and etc. Provide the simulation environment for running quantum program on classical computer. First step, note down, we need to call the constructor of quantum execution environment along with the new keyword. So I will recap. So somebody new to Java programming or not from the computer science background, whenever we instantiate or create instance of an object, so for that what is required? To call new keyword along with the constructor returns the instance of that particular type or the class. So that is the purpose of simple quantum execution environment. Right. So what is help? With the help of simple QE only what is possible? Executing program, step and the quantum gates. That is the purpose of simple quantum execution environment. Right. So in the architecture we have seen Java code converted to API and the API is converted to quantum core layer. Then core layer will be given to quantum hardware or simulator or cloud. So till that everything is going to be same. From where it is going to differs, where it is getting executed, actual hardware or simulator. Then program is the next step. With the help of program object only, we can have gate and we can have the step. So first is quantum execution environment, then program and step. Measurement and result processing. So this is a simple outline of a quantum computing programming using strange. execution environment, step, program, step, and the measurement. We used to say measurement is otherwise result processing. Simulates a quantum measurement process and collapse the qubit states into classical outcome. So during measurement, what is to be given? The program object to be given. The program contains the all operation of the quantum application. So that is given input to program class measurement process. So right now you can take a look. So I was telling you earlier, right, how to instantiate simple quantum environment. New keyword, look at the right side. It is a class simple quantum execution environment constructor. We are invoking the constructor of simple quantum execution environment along with the keyword. So what it yields? It yields the instance of which type? Quantum execution environment, QEE. So we are getting the instance of QEE. Now we are given what? Simulator. So this is the outlet. The first step in any program coding of quantum using Java is quantum execution environment. Right. The next is program class. So next to do the from environment we are entering into the quantum operation. So then with the help of simulator we need to instantiate program class. This program class belongs to r dot redfx dot strange. So from here this class is available. So the constructor of program class takes single argument. So what is that? Earlier we have seen new simple quantum experiment. It is zero argument. We have not given. So but look at here. It is called a program class. The constructor of program class is parameterized. Take single argument type integer. How many integer we are providing here? That will be counted or treated as the those many number qubits. Suppose we are providing 1 or 2, that will be called as 1 qubit. So not called as, it will be counted as single qubit. If we have given the integer 2 or 3, 2 qubits or 3 qubits. So program class only helps us are initializing number of qubits. This is a syntax. New keyword program, as I told, constructor of program class. We are providing argument 1. So means what? 1 qubit will be initialized. So the instance is what? Program, lowercase of type program. Right. So the next step is what? Now we are acquired environment and we acquired qubits and the program. With the help of execution environment and the program class, then we need to do operations, steps and the gate with the help of program instance only. The quantum applications can contain one single step or multiple step. It is instantiated by using step class. The step class is from org.redfx strange dot star, or else we can provide the name of that particular. So the constructor of step class is zero argument. Constructor of step class is going to be zero argument. The syntax along with the new keyword step takes no argument, returns object inserts of type step. With the help of step only we can add gate and we can perform operation. What is it? The purpose is what? With the help of step only we can add gates and we can perform operation. Step, sorry, it is step, not steps. Here I have written steps. It is step. So look at the case. So in Java programming class naming conventions, interface classes should have what? uppercase letter is beginning and what lower cases. Function should begin with lower case, ends up with this parenthesis. Function name and the class name must be different, but regarding constructor name and the class name must be same, and we are having this parenthesis. Right, now we acquired what in the third step. Environment is there, program is there, step is there. Now with the help of step we can add we can add gates. Suppose assume that we are going to use Pauli X gate. So what is required in order to have gate? What is the previous step? Is step dot. Let me leave it to you, I will explain. So there is a function called add gate. After getting insert step, we need to go for add gate. So where it is available? org.readfxstrange.gate. It is available under the package strange.gate. Suppose we are adding Pauli X gate. It takes one argument. So it is the step is what? Instance of the earlier. With the help of step only we can do what? Do operations. Add gate. So we are instantiating. This is what I'm adding Pauli X gate. Syntax for add gate with the help of step instance. Step dot add gate. New is instant. Now we are instantiating which gate? Pauli X gate. Takes 0 argument. So what does it mean? We are providing state. So Pauli takes input state 0. If you are carrying out a valid step operation, then it will throw illegal. So what they are insisting here, at a step, in a single step, we are trying to do multiple operations, then what will happen? It will throw illegal argument exception. Then the code will not execute properly. So if you are familiar with Java programming, you know exception. So there must be exception handling while writing this line. So we must accompany with, if you give anything without your consideration, then what? There should be exception handling, or else it won't throw any exception. Right, first quantum execution environment, then program, step. Now we have added gate. So now we have operation. Then what is to be done? We need to carry out. So measure. Before measure, we should have the processing mechanism of measurement. So it is available with result class. See, Java programming is all about either class or interface. So all we are, so far we have seen is classes and the interface. In the code I will show you which are all classes and the interface. So result class available from which package? org.readfxstrange. See why I am saying then and there, while we write the code, these import statement should be accompanied between the package and the class name. There we need to categorize all the required necessary import statements. Now we are having result. So how we can have this? With the help of simulator instance, quantum execution environment. So that is the simulator instance. With the help of that, result dot run program. Result dot run programs. So it is taking argument of type program. So we need to provide instance of program to the function run program. Run program. So almost we reached the 90% portion of quantum programming using strange. Yeah, look at here, there is a slide stage. Earlier we are speaking about constructor, but what is here? It is a function. This function belongs to which class? Belongs to quantum execution. Do you remember earlier I was saying? So simulator is the instance of QEE dot run program is a function, takes argument of type program. So what is available now in the result? What is available? whatever business logic carried out inside the program will be available in the result instance. So what is that? Now we have reached the end phase of quantum computing sample program. Now we are acquired results continued, right? With the help of results instance, what we can do, we can invoke a function called get qubits, right? Suppose there is a qubit, with the help of what? Result. So what is the instance we are having in the previous step? Result. So right, 0 dot measure. So what is this? The 0 is, as of now, this 0 is my first qubit. So this is the instance of qubit, 0 dot measure. So whatever the value is there inside the qubit will be stored to a variable called value. Syntax for measuring qubit. Then see, you people are very curious about quantum computing, right? And you people in the academic industry, there is a big hype called what? If somebody is going a bigger figure in quantum, right? There must be huge number of publications. You people might come across. Why there is not so much publications are coming from quantum? Will tell you. It is because of the valid circuit. If there is a valid quantum circuit, then only there is a valid quantum output. We cannot fake what? Quantum circuit. So this is what the supporting class responsible for visualizing quantum circuit. Suppose we are having any quantum circuit in our program, that we can visualize by having the renderer function. So this renderer only we are configuring in plugin. So it helps us to visualize human readable graphical format. Qubit, gate operation, gate, and where input we are giving and where we are getting output. So what is a beauty of circuit? Circuit only says what input is given, what operation is carried out, and what is the output we are getting. So that is interpreted with the help of quantum circuit. In strange, it will be done using renderer class. Developers understand the layout flow of the quantum circuits. Visualize quantum circuits, provide graphical representation, quantum programs structure. Right. Example. So how this is the circuit visualization of a simple quantum circuit. Qubit, our gate, and the result. So this kind of visualization we will get. There is a static method, renderer.render program. So in Java there is a concept called static. So for that we don't want the object instance. Straight away we need to write a class dot, that function should be invoked. It takes argument type of program. We have reached, do you remember? We have reached the result. So result is used to measure. So what we are taking? Program. Whatever we have done in the program, that must be visualized by using render program. Takes argument type small program. Small program. And visualize accordingly. Example. So this is a sample circuit. Right? See, so I think let us stop here. So we can have a small break. So we will continue with sample code and we will go to the execution part. Is that fine?